Well, good day, everyone, and welcome to another monthly Sendo Reliability webinar series. I have to think about what we named this thing. Realizing that I've been uh, doing this now for just about 5 years. I think I'm just over the 5 year anniversary of this, and I think I actually only missed one. And when one other one got canceled midway through due to technical problems. But it's been fun, and as you all know, I thoroughly enjoy talking about this stuff and getting your feedback and getting your chats and input into the discussions. And so today we've got a topic that most of you are probably already familiar with to one degree or another. Yet I found that we often limit our view of the cost of unreliability, um, and don't use it as a tool in our reliability programs. And so there's a couple of ways we can go about doing that, and I wanted to highlight some of that and hopefully expand how you think through what all is included in the cost of unreliability, and then what do you do with it in particular. Now, of course, you many of you, I recognize many of the names, have probably heard me say this before, and I'm certainly have written about it, and I've talked about it in podcasts also, is that reliability occurs in the design, right? The ability to create a product that survives the duration of time expected by a customer and not fail is a design function. And manufacturing can only make it worse. So but that's a bias I have from where I started in industry. Yet we work over and over again to design a service or a product or a solution that customers want to buy, and they want to be able to use it for for some duration, and it varies by product and industry. And but that's all happens in the design process. Now, we often do a bunch of testing. Not everybody does, right? And sometimes it's cost prohibitive to do testing, and you may be in a market where you make do very expensive custom equipment, and you're constantly updating and learning as you build each unit. Well, that's a craftsman approach to creating a product or or the reliability into your product. You learn as you go and you adjust. As opposed to the other end of the spectrum, when it's in a consumer market and you're launching a new product and you need to make 10 million units to meet the initial demand, there's 10 million units at risk that really haven't seen customers yet. And it's not easy to go back and fix those things once they're out in the field. And so, depending on your market and your circumstances, so on, you may do more or less testing. Yet I often find that people talk about reliability testing, environmental testing included, stack up to be a significant cost to creating a product, right? Well, many of you have also heard me talk about, well, if you're doing the testing, what do you get for that? And that's a subject for a whole nother discussion. But if you're investing in your product, both in the design and the assurance of it, the testing of it, you should get something in return for that. And that's a hallmark of those two elements. But yet at the end of the day, the customers finally get your product, right? And they're using it for some purpose, right? They bought your product because it was going to solve a problem or make their life easier or be more efficient or whatever it is. Yet they're investing in your product at its purchase price and expect in to have a return, right? And sometimes that returns immediate. It's pretty obvious and easy. A calculator can save you time for me, especially for making mistakes, doing simple arithmetic. Yet it also just is this some like doing long division. It would be a faster solution, saves me time, and the cost of the calculator is pretty inexpensive. So if it worked for one math course in college, it paid for itself, right? Yet those calculators often last a really long time, and they pay for themselves over and over and over again. Whereas other products, it's a trade-off, right? Will this give us a return? If it's a piece of factory equipment, for example, and it costs a couple $1 million, what's the payback period? What might be a question that's asked. Yet the customers are going to determine that, right? And part of creating a product, its feature set and its price point is all oftentimes a very educated set of assumptions and guesses to get that right. And then customers will make that decision. And then they determine what's working or not working, right? Is it reliable or not? Because every customer is going to decide that differently. Some customers want just the plus button and they don't really care about the minus button. So if the minus button fails, they might not even notice. And it's not a failure. Whereas another customer will find it on their first interaction with it and say, oh, no, that's just not working. So it's a failure. And you can use that analogy on all the way out. It's customers are going to be the final arbiter on this. And remember, it's that they're using your product because they want something. They want it to provide them some functions and services as they go on. All right. So here's a question I ask graduate students in the course I teach at University of Maryland. And it's one of the first questions I ask, and it's, so what's the most expensive bit about reliability? What costs us the most? What's the most expensive part? So jump on the chat window there and let me know how would you answer this question? You just what's the most expensive bit? Yeah, letting. So Andrew, where's the expense in that come from? Let's expand your answer just a little bit. Letting problems escape to the field. Yeah, it's much, much higher cost to fix. And that's very true, right? There's a kind of the adage of costs, yeah, more paperwork too. It costs 10 times, 6 to 10 times more per phase during the development process. So if you catch it in concept, it might cost $10. If it catch it in prototyping, it's $100 and so on. And then it costs way more out there. Yeah, and getting people out there to fix it. So yet the idea of fixing it later, um, yet I mean, it could include all kinds of different things that cost money to make that repair or that change. And kind of the worst case is when it's a big public recall, right? And you got to pay for all the return everything, even if it's not failed or not. Yeah, and Mark, not knowing what the cost of unreliability equipment is, and what do you mean by that? And this might tie more into a future question, but you know, and that's what the whole issue of this podcast is. So let me come back to that one, Mark. We'll come back to your comment. All right. So keep in mind that your product goes out to the field, and we attempt to design and manufacture it so that it works. And there's only one business I know of that really does need the products to fail, otherwise they don't make much money. And it's the and it's not every one of them, but I've run into a few, and they're bound by contract to military equipment. Um, that it's really a cost plus design process, and if they sell it at a particular price, they basically just barely break even with a small profit margin on it, and it's very tightly controlled. But they also generally, um, if something fails in the field, they're the only ones that can fix it. And there they can renegotiate and charge a much healthier profit margin to make that happen. Most everybody else doesn't play that game. And we basically just want our products to work, right? It costs us a lot of money to fix things once they're in the customer's hands. And it costs us a lot to fix things no matter where they are. Right. Now, let's say what happens when a prototype fails? We're building a product, we're designing stuff, we're getting some prototypes. If you give them to somebody like us, we're going to see if we can make it fail. And it, right? What the basic idea here is that's okay, right? It's okay. Well, hopefully your organization deems it this way. Excuse me, still haven't got that voice up, warmed up. If a prototype fails, hopefully your organization treats that as an opportunity to learn something, right? It's failed, it's not meeting our criteria, our thresholds, it illuminates something that's not quite right yet, and it allows us to improve the product, right? Prototypes are built for, in a large number of reasons, is to see if the functions that we expect to work are working. And so when they don't, it's a failure of a prototype, right? Now, there's another kind of prototype failure is when it's just not assembled correctly and there's errors made and it just doesn't work. Well, I look at that as another opportunity to learn about, well, how do we manufacture these things? How do we build these things? Is our supply chain in place to help us create products that will work when we go to production and so on? But a prototype fails. I mean, it actually does cost us some money, right? We lose that prototype in order to explore more things. I often use the analogy of a river with the water being going down. And the first thing you see in the water is the big rocks, the big issues, the big problems, and we go solve those. And the water level goes down some more. And then there's, if you're lucky, there's another great big rock just under that surface, and we fix that and go on down. But eventually it goes down, and then there's lots of little rocks, and we have to decide if that's good and we add enough or not, and we release it. Well, the point is that by fixing an issue, identifying a prototype fails and we fix it, it may be masking the next big rock that we just barely missed. And not having that prototype available means it may take us longer to prototype. And if it doesn't, or we might not see it at all. And so prototypes failures cost us not only the cost of the prototype, which you can argue of setting up the or point of having it was to see what fails. Ago, I also means that it doesn't reveal the other issues that it could reveal to us. And so there's a little bit of a cost factor in that by not discovering what we want to. I tried using that once as an argument to get more prototypes, but it didn't go very far. But I ended up duct taping and baling wiring together the one prototype I had to get as much out of it as I possibly could. Excuse me. Got a little frog in my throat this morning. All right. The most common answer I get, and it's similar to what came up, Andrew, what you're talking about, is it's expensive to fix something once it's in the field. It's expensive to redesign it. It's expensive to maybe scrap part of our production and materials and maybe do a recall. It's expensive to ship people out to go fix things. Always makes me think of the IBM approach to field services. Somebody would have a problem with the server and there'd be a plane load of people in white shirts, men in white shirts and black ties. They go fix stuff. But a warranty is often the answer for my graduate students as the most expensive part of the warranty program or of the reliability program. You know, and testing's pretty expensive too. Yet when warranties say 2 to 5% of your net revenue, and your product development teams is say 5% also of your net revenue. I remember at HP, they were pretty proud that it was like between 7 and 10% of net revenue was devoted to product development and R&D work, whereas the warranty at the time was 4.5%. 4%. And it was there was nobody looking at warranty and warranty reduction and how to reduce those numbers. Whereas there were hundreds and hundreds and hundreds of managers working in their R&D development teams and managing those budgets and extracting as much return for investment out of it. So once we made that point, and this was years and years ago at HP, there was a whole lot more emphasis on warranty and warranty reduction. But remember that warranty, what you and your organization count in warranty or in field service, whichever kind of business you're in, is up to you and your accounting team, right? If you uh, follow the e-newsletter, it's free, by the way. I should actually probably type it in here. Let me put it in the chat window. It's the quickest. Is warrantyweek.com. And it's by type it in. So if it worked, Arnhem, he's actually a whole journalist by trade. And about 10, almost 15 years ago, he started this newsletter and he tracks the reports to the SEC of publicly traded companies that at the time were just starting general. One, if the organization required to report their warranty accruals, how much money they set aside for future payouts, and how much their actual payouts are. And now he's got 10 plus years of data and he can follow trends and it's all very interesting. But he regularly reminds us that every company determines what they count for warranty, what goes in that bucket or not. Some include call centers, some don't. Some include parts and repairs, and some don't. Some count the cost of manufacturing or the cost of redesign, the R&D work, and so on. Many do not. I know at one point I'm sure I've mentioned it here in the webinars is that one of the costs that's often hidden, and it's not often part of the warranty claim, is the cost of redesign. Now, some organizations have a whole group of engineers that might be in the manufacturing or operations team, or they might be part of the design team, but they're devoted to products that are launched to the field that issues come up and then that needs a redesign to fix. And they may have 5, 10, 15 people just focus on fixing old products problems, and updating them. And part of their charter is also add new features and update and refresh and so on to some extent. But oftentimes I find that they exist to shield the R&D team from having to deal with field problems. And I think that's kind of a backwards look at things. If the folks designing the product don't realize the impact of their mistakes and how much that's really costing you and your organization, um, they're going to continue to make those mistakes. And more mature companies actually get more feedback into that element. But when you look at Warranty Week or you look at warranties in general, there's always that analogy of the tip of the iceberg. And it really, really is. And I want to get into that a little bit more. Right? What does it cost the customer when your product fails? Right? And this one's harder to always get your handle on. Yet, if the cost to the customer was nothing, right? Why would they call you, or why would they expect a return or repair or replacement? Why would they care, right? Think that through a little bit. Now, realize that I used the story I heard years ago when I was talking to one of the server groups at HP, is they were providing servers at that time to, I think, eBay or one of the online commerce companies, something like Amazon. And it was a big online retailer. And if their server went down such that they couldn't process orders for new sales for whatever their products were, it was something on the order of $1 million a minute of lost revenue. It was astounding amount of expense that they they knew what the ratio was, but they didn't get all of that back. People didn't wait. If it wasn't available here, I'll go buy it somewhere else, kind of thing, right? So when your product goes down, it costs you money in warranty and in attributed costs that trickle out from that that may not be reported as warranty, and which are often much more expensive than the warranty itself. But the customer also loses, right? Your product's not solving that problem for them. Your product's not providing that function or service, right? And they have that function or service there because they want it to process transactions, for example, or schedule appointments uh, for the hair salon, or whatever it is your product does. And if it doesn't work, it costs them money, right? They're not getting the return on investment that they wanted from your product. But what else? What else does the customer have the potential to lose for your product, right? What happens when your product fails to the customer? Yeah, lose their customers. Yeah, well said, Julie. I often lump that into the brand, right? Is the cost of acquiring a customer in the marketing parts of this is that trust is a big part of that. Now, it obviously this depends tremendously on what your product is, right? Some products, like a vehicle, if the brake system fails, um, you not only can you damage the material, you could damage other vehicles or road systems, or loss of life could happen, right? That's a hard way to lose a customer. Um, the the customers, they could lose their customers, right? The confidence, exactly right, Andrew. And so it could cost you more to acquire, and most marketing teams know that there's a cost to acquire a customer, a cost to acquire a brand new customer, the next additional customer, includes commercials and Super Bowl ads and flyers and brochures and conference attendance and trade shows and magazine articles, and they do all kinds of stuff in order to help you decide to buy their product. Sales visits and calls and meetings and so on. But when it's a customer that is an existing customer and they're happy with your product, it's much less expensive to, in general, to have them buy again, right? If they're not satisfied, it's more difficult. And if they're dissatisfied enough, they're just not going to buy again. And reliability plays a role in that, obviously. Now, if your product fails, right, it could go from simple annoyance to they figure out a workaround. Sometimes they don't even notice, right? That can happen, and it probably happens more than we think, all the way to it kills them. I mean, literally causes loss of life. Or I think of it as I was working with a team that made wafer fabrication equipment. Right, it goes in a clean room that had these, all this wafer fabricating equipment, all these wafers out there. A little, I mean, not a lot, like part per million type levels of contamination, uh, pretty much made those wafers useless, right? And so it'd be millions and millions of dollars of lost materials and tens of millions of dollars of lost revenue if this if the fab got contaminated. And so if you put a piece of equipment in there and it catches on fire, that whole building, that whole room, wherever it was contained, um, not only makes an unhappy customer, right? It costs tens of millions of dollars. If a sensor in a chemical processing plant fails and a pressure is not detected building up and a vessel explodes, right? That could be pretty darn serious. Uh, if it's a product like a home phone and a solder joint fails on it and it no longer has a dial tone, depending on the circumstance, that could be very serious. So it ranges all over the map, and every product has its different realms of impact on your customer. And so part of the FMEA process, and it's something we'll talk about here in a moment, is, well, what is the consequence to your customer, right? What does that really add up to? Now, the point here is that as you think through these consequences, and many organizations know and talk about these consequences, but I think part of this message of this webinar is we need to quantify it and actually make it real, so that it's part of that trade-off decision process of designing a good product. Now, the consequences, I mean, it's part of our warranty costs or maybe not, but we have to do things to sort out what's going on with this failure. Everything from failure analysis to qualification costs to scrapping product and materials to re-educating customers, sending out patches, updating the menus and responses in the call centers. These internal costs are not trivial, yet my argument is that they pale in consideration of what it does to your brand, and there's a tipping point here, right? And to what it costs your customers ultimately. Now, a couple of times I've run into organizations that regularly did customer satisfaction surveys and polls, and they did use a number of different techniques to do this. And I'm sure every one of you have seen these at one point or another with products you've purchased or even within your own company. But one of the marketing teams showed me why reliability was important. And I says, what do you mean by that? And he goes, you're in marketing. Now, I don't much like marketing people all that much. When they show your product in environments that it really won't work in, that kind of is irritating. But they explained that 1 point of improvement in the customer satisfaction survey, and there's one survey that says, would you highly recommend this to your friends, for purchase, or would you recommend it? There was like a 5 point scale on a Likert scale, and if it was in the top two band, that percentage that was in that, if it moved 1% higher, it meant, and they had a number for it, um, less costs to resell, right? They could quantify the value of customer satisfaction in the cost per sale of the marketing effort to acquire a new customer or to retain an existing customer. And they had very specific numbers on it. And so as the customer satisfaction went up or down with new products, they quantified it and they knew exactly what that number was. And it wasn't trivial. It was like for $1,000 product, they were down into like it was $300-400 difference to acquire a new customer versus retain an existing customer for a 1% change in customer satisfaction. It was pretty big, and I was shocked. Now, of course, every product will vary, but it's a question to ask your marketing team is, one, how does reliability or the perception of reliability impact your brand? And then if they are doing customer satisfaction surveys, how much does a change in satisfaction affect the actual cost of a sale? And then this team went one step further, is why they were talking to me, was they knew that 80 to 90% of the factor, the dominant factor, well over half the attributing cause to customer satisfaction was the reliability of the product. And that went because of the way it was sold and how it was used and its perception and so on. But customer after customer said this product works or doesn't work based on its reliability. And that drove the customer satisfaction. So brand, though, to me, I don't fully understand how it's valued. Yet it is on the accountant spreadsheets, right? It's in the ledgers. It's a quantifiable asset an organization has. And then we mentioned this earlier with a couple of examples, like the server going down and not able to process transactions, those kinds of things. Some customers buy your product and they expect a They don't even calculate what the ROI is. If it works for a while, they're happy. It does what it's supposed to do, like a calculator, right? But it doesn't have a high enough price point that they're upset when it fails. They might be inconvenienced and go get a new calculator, um, but then they'll drive right on. They don't sit down and calculate it. Now, in that wafer fab facility, there's a team of people looking at, are we getting a suitable return for what we paid for this and how much it costs to operate, right? Now, if it fails, that factors into that calculation in a serious way. And so thinking through that cost of the loss of use and talk to customers, uh, run out those calculations, get some hard numbers so that you can quantify that. And oftentimes that is rather a surprising a large number. And every time I've ever done this, it's much, much larger than warranty losses. We're just scratching the surface on this. Years ago, I got called by um, I don't know where he was in the organization, by somebody at IBM, and he was asking me about our reverse warranty charges to our supply chain. Like, what do you mean? And he said, well, if a server fails and say it's the power supply, we charge the power supply vendor not only for the cost of the power supply, basically a warranty claim back to them for the part that failed, but we charge them for the loss of the entire server, right? So if you were making some capacitors and the downside was if your capacitors failed at one of these machines, you paid for the $20,000 or $50,000 piece of equipment, not just a 2-cent part. That's a different contract, right? There's a little different motivation there. And they said they were regularly claiming $100 million of these back charges to their supply chain. They were shifting the burden of the warranty back to their supply chain whenever they could. Now, we never did anything like that at HP that I knew of, yet it was an intriguing idea as a motivation for your suppliers to send you good parts. Um, I think our approach at the time was just make a really robust product and by design, and then you'd just have less failures. There's many ways to go about doing that. But if you understand the loss of use of your customer, we're probably glad they don't have that contract with us that if our system goes down, we pay for it. Now, there are some industries where that happens, right? If your product fails, you pay for their loss. And sometimes it turns into lawsuits. All right. So, how do we use this information? The cost of unreliability is got to move out of being, yeah, it's expensive when it fails, right? We have to move it out of that. And if warranty is the only number we have that we can actually put a number on and quantify, I mean, that's a start. But we also generally realize it's just a fraction of the total cost of unreliability. So we need to calculate it, right? We need to come up with some numbers. And one of the things that I've advocated over the years is, well, what's the cost of warranty? For example, what's the cost of warranty per unit shipped? And I learned this from Dick Moss when he was at HP. And I was just getting started in the reliability realm there. He said, think of it this way. We sell a laptop, for example, for $1,000. There's all kinds of components in there. The IC might cost us $50 or $75, for example, or the motherboard might cost some number like that. We have a few expensive components. Everything else is not terribly expensive. He said, but what do you think is the cost of warranty compared to all of these other components? No, I have no idea. I know that we pay X amount in warranty for these products. And I said, I think I could figure it out. We ship so many products. And just off the top of my head, I did a quick mental calculation. It says it's like $100 per unit shipped. Because when a $1,000 laptop failed, it didn't cost us just $1,000 because we had to create a new laptop and ship it out, and then there was other associated costs with loss of brand and all the other things that we generally didn't tabulate into the warranty cost. Um, the general guideline is to use for mostly consumer products is in some industrial B2B products is it costs your warranty expenses are roughly 2.5 times the retail price, and for all the attendant costs that go into it. Now, the more your finance group tracks all this stuff, the more accurate it'll be, but it's a starting point. So let's say 5% of these things failed and it cost us $2,500 per, and we got so many failures. If I work out the math real quick, it's say $100 per unit shipped. And I says, that sounds like a lot. And he goes, think of it this way. We assemble the motherboard, we wire up the power supplies, we put in all the components, we put in a manual, we put in the instructions, oh, this is years ago because they were still printed manuals for these things for some reason. Maybe they failed too often. Um, and you put in $100 bill. And he said, well, we don't do that now. He says, but we do on effect. For the ones that failed, we spend a couple $1,000s. And on average, it's $100 per unit shipped. And I said, but that's more expensive than anything in this product. He goes, exactly. And I've run that exercise with many, many clients over the years, and it is usually the most expensive component. I'm using these air quotes here, the cost per unit shipped. And that's only a fraction of the cost of warranty only captures some of the costs. So the requalifications, the redesign, the scrapping of materials often don't fall under the warranty costs. So that's just a fraction of it. And so by quantifying it that way, that if your team is looking at cost of components and your procurement team is trying to drive down the cost of components, procurement team, so it, for example, if you put warranty in those same terms, now it brings attention to, hey, this is pretty expensive compared to all these other things we're trying to do cost reductions. Let's just make it more reliable and we can save a whole lot more money, right? Internally. If you The other part is at the customer side is quantify that. Make it real. And it might be a distribution given the range of your customer base, but make that a visible, quantified number, right? Make it actually real and use it in cost per failure or cost per unit shipped so that it becomes comparable to the other ways people are talking about, say, component costs within your organization, right? That's not enough. The next step is to connect it to your business, right? The the problem is that some of these costs, the customer's costs, don't come back and hit our bottom line. Now, in some businesses, customers then go and sue you, right? And they want more restitution than just the warranty line. And that could certainly hit your bottom line. But by and large, that's rarely occurs. Recalls varies by industry, but generally, overall, it's a rare event, right? It's much, much more likely that that loss of customer satisfaction does hit your bottom line, but not directly, right? It erodes. As your customer satisfaction erodes, the opposite occurs. It then getting easier to sell products, it becomes more difficult to sell products, right? That can be quantified. It, believe me, it's work. Unless your teams are already doing it, it takes a lot of work to get good numbers there. Create a structure, make some educated guesses, bounce it off a lot of people, get better data as you can, but get that conversation started. Warranties direct, right? Warranty accruals and warranty expenses are direct, they're on the bottom line, but keep in mind that they're only a piece of what we're doing. And instead of saying we're paying $3 million in warranty this year, is how much is that per unit shipped? Make it real to the decision makers that have to consider the effective costs that are out there. And then build it into your product lifecycle. Build it into the milestone checkpoints, build it into your reliability program, make it a part of enabling all of those decision makers to fully understand, right? What is the cost, both internal and external, of a failure? And it what it does is it enables them to use that information because they know where it's coming from. They understand how it's impacting products. They know then how to translate that into, do I buy a less expensive component that increases our failure rate? Or do I buy the more expensive component that reduces our failure rate? Or do I add cooling? Or do I add redundancy? Or do I, whatever it is, or real that keeps the product working for your customers so that you don't trigger this cascade of costs of the unreliability of a product. But if it's not tangible and in a form that's usable by those decision makers, um, it becomes very difficult for them to do, oh, yeah, we know it's expensive, but I don't, they're looking at bill of material costs and time to market. They need the balance. And so part of our role is to make these costs very known, along with, well, how do you use them? How do you make these trade-offs? Right. I think this is my last segment is that the cost of unreliability is a risk, right? And it's unknown to a large degree, and quantifying it and understanding where those costs come from is part of that process, right? So identify it. We do this already. This is what we do. We walk into the room and say, hey, that won't work. And here's why. Here's all the science. Here's the chemistry. Here's the issues. Here's the statistics. This is what we expect is going to happen. But we use tools like FMEA and HALT and others to expose failures, expose weaknesses, to understand where the threats are. Where do we need to go look? How do we manage and secure a stable manufacturing process so that we don't make the design worse than it already is, or as good as it is, make it as good as we can. Spin it positive there every now and then. But we do this already, right? But by adding the cost of a failure to this in these kinds of terms often makes the difference of whether we take action out of it or not. And so having that infrastructure in place of having a well-characterized cost of unreliability across your entire product lines and life cycles helps that when you say find something in HALT that will affect 1% of your products, it's a pretty easy set of mathematics to figure out, oh, that's going to cost us $384,000. I need to fix that, for example. All right. In my experience, I found that making friends with somebody over in finance, especially somebody that really wants to do uh, ABC was the acronym for it. Activity-based accounting for it was the ABC. They phrased it. It was a buzzword, or maybe it was 20 years ago, but oftentimes the way it was the ABC. It's the details of these transactions that occur within our organizations that these folks really, and like a microeconomics type focus, can dig into and find the numbers and understand how to measure this stuff and provide the rest of the team the information necessary to make, do we go with vendor A or vendor B? And it includes the effects of reliability or unreliability per se. Um, I don't have those skills. I work on details and always look for a finance person to partner up with that could help me that tease out where these details come from and get some support for the really organizability outcome reliability from the finance team and from our actual numbers to support the claims we're making about unreliability. And then the last step is another part that we do already, and is we design it out, we make our processes more stable, we work with our suppliers to sort out where the risks of reliability are and so on and mitigate those. We do a lot of work to do this. I have found over and over again by having a good understanding in place in an organization of the cost of unreliability goes a long way to make this mitigation step a lot easier. Ideally, we're doing this in the design for reliability aspects, right? We're doing this well before we get products failing in the field, and that's even better. But all along that way, having that understanding of what's the cost in a tangible way that's well understood makes this step much, much easier. So, what else can we do, right? Part of it is we can make a very, very robust product. Yet, early on in my career, I ran into this realm, and it was even when I was in the quality organization in some parts of my career. It was the intent was to work yourself out of a job. So if things were going well, if production was humming along and we had plenty of uptime and our products were having a decreasing failure rate and customers loved our products and we had good customer satisfaction rankings and we're doing all these things that were just going along great. I had an operations manager look at me once and go, "So, why are you here? We don't have a reliability problem, right?" And I wasn't prepared at that time. I wish you are, I hope you are when you hear this question, is it's because of setting up these structures, of setting up this understanding, of enabling good decision making throughout the organization that makes you don't have to go fight fires. You don't have to jump on a plane and go do failure analysis. You don't, all of those things that are reactive just don't have to happen. That doesn't happen all by itself, right? So if you're in an organization where there's, well, we don't have a problem, why do we need a reliability engineer? Having a very clear, well articulated understanding of what's the cost of unreliability can help you get through that discussion a whole lot easier. And in most cases, when that case exists, when people intimately understand the cost of unreliability in all of its facets, those discussions don't come up, right? Nobody says, why are you here? We don't have failures. They understand that it's an investment so that we don't have failures. And there's a value in that. And so that's that's what we can do. And I look at all the other aspects, at all the other functions we do, from doing FMEAs and setting up tests to doing failure analysis and everything in between are enhanced by understanding and having in place a really good cost of unreliability structure that everybody understands. So anyway, that's the presentation. I should have jumped on the chat window a few more times. I think I got myself on a roll here. Um, Basically, we work to make products reliable. That's the positive side. It's a complement to the unreliability part of this. Oftentimes, our organizations see not only our salaries, but the cost of prototypes we're going to go break, the cost of redesigns, the cost of warranty as all expenses. And you can argue that they are. Now, you can flip that. If we can minimize the cost of unreliability to us and our customers such that our warranty goes down and our brand um, uh, customer satisfaction goes up, right? Those are real benefits to an organization. And sometimes there's very, very significant. And you can manage that and make it happen from where you sit. And then we end up with less unreliability, or the converse of that is the complement of that is we have more reliability. And it just is a virtuous network at that point, a virtuous cycle. So anyway, that's today's presentation. Let me go over to the conclusion slide. And I'll stick around for any questions, anything that you guys like to ask about, or if any stories from your organization of what's working or not working, I'd love to hear those.